Ever wondered how Netflix knows what to recommend or how your phone unlocks with a face? That is machine learning, and in the next few minutes, I'll teach you the core concepts behind that. So first off, what is machine learning? Machine learning is when computers learn patterns from data instead of being told what to do line by line. Think of it as teaching a system how to learn rather than hard coding rules. We provide the model with a dataset which is divided into two parts, the training set and the test set. The training set is used by the model to learn stuff, and the test set is used by the model to evaluate its knowledge. Data is the main component in machine learning as it fuels the models. It all starts with data, as without data, AI model is just a blank slate. The better your data, the smarter your model becomes. Think of it as teaching a child how to differentiate between cats and dogs. You have to show the child pictures of cats and dogs before he can learn to differentiate. Say this is an example dataset where we have the sepal length, sepal width, and different species of an iris flower. So here sepal length and sepal width are the X values or the feature values, and the species is the Y value or the target value. Let's look at this dataset in detail. So the first two columns are the X values or feature values. So the feature values are basically also called the independent variable, as these are used by the model to predict the Y value or the target variable. We always provide the model with the feature value, as feature dataset contains all the data that is required to predict the Y value. Here, the sepal length and sepal width are the data or the feature data that is used to predict the species or the target data. We've been talking all along about machine learning models, but what is a model? A model is just a mathematics-powered box that learns the patterns between the input and the output. You give it features and labels, and it figures out how they connect. You give in the X values, and then it gives you the Y values after learning from a dataset the relation between the X and Y values. There are basically three types of machine learning. The first one, supervised learning. Here you provide the model with labels. Labels are basically the marked Y values or target values where you have a right or wrong system. Supervised learning is divided into two types, that is, classification and regression. In classification, the model has to predict values like classes or groups, such as whether an organism is a mammal or a reptile. In regression, however, the model has to predict continuous values like the sales of a company. In unsupervised learning, the target values or the label values is not given to the model. It doesn't know what's right or what's wrong. It basically takes in a group of features, plots them, and makes clusters based on the similar data points. Supervised learning is about finding the relation between the X and Y values, and unsupervised learning is about finding the hidden patterns in the data. Next up, we have reinforcement learning, where it learns from reward-based system. Like the model has to achieve a task to get a reward. Now comes the process of making a machine learning model. A machine learning model is made first by the pre-processing of the dataset. This includes the splitting of dataset into the train set and the test set. As I said already, the train set is used for training purposes, where we show the model the X values and the Y values, and it finds the pattern or relation between them. And then we give the model the train set and then match the model's predictions with the actual values. Pre-processing also contains several methods such as normalizing or scaling of data, where we adjust the data to have a desired mean or variance. Then comes choosing the right algorithm. As I've already said, machine learning is nothing but a bunch of algorithms. So there are different types of algorithms for different use cases. So we have to choose the right algorithm first. Then comes training, as the machine learning model is supplied with the training dataset and it understands the pattern between the data. Then we have to test out the model with the help of the testing dataset, and then we have to evaluate the model predictions with the real outcome values. Since we've been talking about classification, regression, and ML models, we have to talk about KNN or K nearest neighbors, which is specifically a classification type model or a supervised learning model. So KNN basically plots the data points in an n-dimensional plane where each of the dimensions, for example, here we have a two-dimensional plane, so this is the y-axis, this is the x-axis, and each of these axes contains different features. For example, this is the first feature and this is the second feature. So the model plots these data points and then checks what is their target value or what class are they in, such as we have the red class and the green class here. And then it plots the data point that needs to be predicted and looks at n nearest neighbors. Here n is a constant that is given by the user. N is also called a hyperparameter that can be adjusted according to the needs of the user to get the most model accuracy score. Now, it looks at the n number of neighbors to this data point and then checks what is their class. The majority of the class is given to this data point. For example, here we have 3 neighbors, so 3 of the neighbors are of red class, so this data point will also be of red class. Next up, we have 2 important topics, that is underfitting and overfitting. Underfitting is when the model is too simple and it misses the patterns in the data. Overfitting is when it memorizes everything and is very noisy. For example, a single data point may cause errors in an overfitted model. We always aim for a balanced dataset, which can be attained by the adjustment of the hyperparameter, for example, the n in k nearest neighbors. And that's it. You now know all the basics of machine learning engineering. Make sure to like this video and subscribe to the channel if you found this helpful, and comment me down below if you want more ML videos. Thank you for watching. See you soon.